naughty. Half the class. All right, so now I'm going to move to the elimination of alcohol. So basically, the concept of the elimination of alcohol is just similar to that elimination of alkyl halide. Okay, so except that for alcohol, you need these extra steps. Okay, so where you need to make the OH a good leaving group. So this will always be there. You must add this step before you proceed with the mechanism on elimination and so on. All right, okay. So the general dehydration reaction, okay, is going to be like this. Okay, so you are going to react this, what do we call this, your alcohol, okay, with your acid. Okay, so this is alcohol. Okay, you are going to react with acid. Most of the time we use acid H2O, sorry, H2SO4. Okay, most of the time it is H2SO4, or it can be the p-toluenic acid, but not common. Okay, so and then what you are going to produce is you are going to produce the alkene. Okay, and as a side product, because the name of this reaction is dehydration, right? So you are going to produce water as the side product. Okay, so water, this water is the side product, or sometimes you call it byproduct. Okay, so now how does the mechanism goes? Okay, so we have mentioned, okay, yesterday I have mentioned that, okay, that the reactions is just going to be similar to alkyl halide, and this reaction follow the Sitzer rule. And in terms of the mechanism, it is going to be much easier because you just need to look at the alcohol. Don't care about the what the nucleophile, sorry, the base and so on. Okay, so here, okay, you have you are going to see that the secondary and are you sure? Okay, the primary alcohol. Okay, so primary alcohol go with E2 mechanism, secondary and tertiary go with E1 mechanism. Okay, so it is a clear cut when it comes to elimination of alcohol. It just depends on the, what do we call this? It just depends on the types of the alcohol. Okay, so if you have problem to identify whether it is primary, secondary, or tertiary alcohol, then it might be a problem a bit to you. Okay, so wait, where is it? Okay, so now, so what is the steps? Okay, so we are going to go with one by one. So, okay, first of all, you should be able to predict the product. Okay, so again, this one, it follows the Sitzer rule. Okay, meaning to say the reaction, the elimination reaction, they are regioselective. So what is regioselective? Meaning to say it is selective to produce one type of constitutional isomer. You are going to see two terms, okay? One is regioselective, okay? Number two is stereoselective. So if regioselective, it tends to produce one type of constitutional isomer. So meaning to say you're going to have major and minor product. That major and minor product, you are talking about the regio is like region, okay, where does the pi bond will be formed, okay? So in terms of stereoselective, this one you see in a substitution reaction, okay, especially for SN2. So stereoselective, meaning to say that you are going to produce a specific type of stereoisomer, okay? For example, in the reactions that we have, okay, if you have R alkyl halide, you are going to produce S alcohol, something like that, okay? So I'm just going to leave this because it's just a basic things that we have taught you. Okay, so now I'm just going to proceed with the, what do we call this, this module, okay? So I'm not going to go with the lecture notes, okay? You can go through the lecture notes, okay? Because the concept are just similar, okay? So remember that we have additional step. The additional step is at before the reaction proceed, okay? So one is step of formation of H2O leaving group. Why you need to do this? Because OH is not a good leaving group, okay? So what are you going to have is you are going to have it like this, okay, OH, all right? So as you know, oxygen is a good, oxygen is a nucleophilic site, right? So you are going to react it with H2SO4. So you need to know what is the structure of H2SO4. Okay, so when it comes to H2SO4, do you need to draw the Lewis structure? No, you just need to draw something like this. Okay, look at this one, HOSO3H. Okay, so H, oopsie, okay, OSO3H. Okay, as you see, this is sulfuric acid. So you must attach the hydrogen with the oxygen in the sulfuric acid because you want to show that the electron goes to the oxygen later. Okay, so now, from the oxygen in the alcohol, okay, so the lone pair from the alcohol will take the hydrogen from the acid here. So you see, so this is actually acid-base reaction. So what happened to the bond? Okay, so what happened to the electron inside the bond here? So what happened to it is that it is going to go to oxygen. All right. Okay, so you are going to form oxygen, hydrogen, sorry. Okay, so the two electrons from the lone pair will be used to make bond with the hydrogen. Okay, so you see this one is a bond. Okay, so your oxygen is going to have a positive charge. Why? Because of formal charge. So as a side product, you have plus negative OSO3H. So this is going to be like this. All right. Okay. So for this step, any questions? Do you have any questions? No? Okay.
No, madam.
All right, so if you have no question, then I'll proceed with the next part. Okay, the next part is that you are just going to take this one, okay? I'm just going to paste it here. Okay, so so you see that now you are forming a good leaving group. So H2O is a good leaving group, so it will leave easily. Okay, so now when you want to do elimination, oh, I forgot to predict the product, but I think I did. Okay, did I? Oh no. Okay, so first of all, of course, you need to predict the product. The product is going to be like this. Okay, so the double bond, okay, is going to form between alpha and beta carbon. So you see, this one is your alpha carbon, all right, and this is your beta carbon. Okay, so when you have alpha and beta carbon, you know that the bond, the pi bond, is going to form in between alpha and beta carbon. Okay, so you need to remove the hydrogen, okay, from alpha or beta carbon. Where do you remove your hydrogen?
Beta.
Beta. Okay, good. So we are going to remove the hydrogen from the beta carbon here. So hydrogen here. So this is what you want to remove. Okay, so how is it going to go is that, okay, you see there is a electron, right, on the oxygen. So this one, it is going to take the, what do you call this, beta hydrogen. Okay, so then what happened to the two electron inside the bond between the beta carbon and beta hydrogen? It will go to alpha, between alpha and beta carbon, to make the pi bond. Then the next step is that there is two electron, right, between alpha and oxygen here, alpha carbon and oxygen here. So this one, it will go to the the oxygen. Okay, so what happened here is that, first of all, let us look at the green arrow here. Okay, so for the green arrow here, what happened is that the oxygen from the OSO3H is going to take the hydrogen, so it will form H2SO4 back. Okay, but now it is taking the different hydrogen, not the hydrogen coming from this one. Okay, all right, not this hydrogen. Okay, so this one is going to take the beta hydrogen. Okay, so what you are going to form is that you are going to form OSO3H. Okay, so you are going to have it like this. Your 2 electrons is going to form bond with hydrogen. Okay, so you're going to form bond like that. So you are producing H2SO4 back. Okay, and then now look at what happened to the bond here. Okay, so this one. So what happened here is that it is going to form pi bond between alpha and beta carbon. So it is going to be like, sorry. Okay, so let me just leave it. H10. Okay, so now you see these 2 electrons, okay, these 2 electrons is going to be transferred here. Okay, they are making the pi bond. Okay, and then you see there are 2 electrons inside here. Okay, so where does this electron will go? Okay, will go to the oxygen. So basically this bond is going to be broken. All right, so and the oxygen, okay, is going to take the electron with itself. So you see the oxygen here, okay, the water here is like this, H, and then you have hydrogen. Okay, so like this, and you are going to have the 2 electron going to the oxygen. So you can see that you are forming your product. Okay, first of all, you are forming your product, which is this one. You produce it, correct? It's the same. So now you are reproducing the H2SO4 back, and your side product is going to be H2O. So this one is going to produce H2O as the side products. Okay? So far, any questions? Okay? No question? Okay. All right. So I will proceed with the E1 mechanism. Okay? So for the E1 mechanism, the steps are just going to be the same. So if you have a look at this part, okay? So this is for the E1 mechanism. So if you still remember the E1 mechanism, elimination reaction in alkyl halide is just going to be the same. So now look at this. This is secondary alcohol. Okay, and then you have your acid. Okay, so acid can be HCl, can be H2SO4. Okay, but common one H2SO4, but still possible we ask with another acids. Okay, so first of all, look at your product. Okay, so what are you going to produce? You are actually going to produce, okay, so where is your alpha carbon? So this is your alpha carbon. Okay, so you need to locate your beta carbon. So your beta carbon is here and here, all right? Okay, so this is your beta carbon, your beta carbon. So you are going to have 2 products, okay? So one is going to be like this, okay? And another one is going to be like this, all right? So, and then you are going to produce water, of course. Okay, so between, okay, the product A and B, which one is going to be the major product? Okay, actually you're going to have another one, which is cis, but usually it's fine. Okay, so let me just draw it. So A, B, and C, which one is a major product?
A.
Okay, A. All right, because it's a trans alkene with more substituent. This is the most stable one. Okay, so this is a major product. So let us just draw for the major products. Okay, minor. Okay, So this mechanism I will just show for the major product. Okay, so now the first step is always the formation of H2O. Okay, so it is going to go like this. Okay, oxygen, hydrogen, right? So you have it like this. Okay, so now you are going to react it with acid, HCl. Okay, HCl. Okay, so all right. So this one, first of all, the electrons from the oxygen, okay, from the oxygen here is going to take the hydrogen from the acid. So what happened? The bond between hydrogen and Cl is going to be broken, in which it will go to the Cl. Okay, so you are going to produce it like this. Oxygen, hydrogen. So these two electrons, okay, will be used to bond with the hydrogen. Okay, so you see, this is bond. Okay, so now this is going to be positive charge. Okay, so plus Cl minus. Okay, so the Cl minus here is going to have in total 4 lone pairs. Okay, so once you have that, okay, we are just going to proceed with this one first. Okay, why? Because in elimination reaction, when it comes to E1 mechanism, you are going to produce carbocation first. You are going to have intermediates. Okay, so the first step is going to be like this. Okay, so in between the alpha carbon, okay, and the oxygen, there are 2 electrons which make the bond, correct? Okay, so now this bond is going to be transferred to the oxygen. So as a result, okay, so as a result, it will become positive charge here plus, okay, OH2. Okay, if you just want to write H2O, that should not be a problem. Okay, so I just want to show you clearly. That's it. Okay, so you are just going to get that. So this is the carbocation that we are talking about. Okay, so now, okay, so do you want to use water or do you want to use the Cl minus again to form the product? Okay, so it will depends. There is no problem. Okay, so there is no problem. You can see here a base such as HSO4 minus or H2O can remove a proton. So in this case, in our sense, it is Cl minus. So it should not be a problem. Okay, you can use whichever that you likes. Okay, so if you think that using Cl minus is going to be clearer for you, okay, because you want to produce the HCl back, then by all means you can use it. Okay, so for your level should not be a problem. Okay, so what is going to happen is that, okay, you see this is your this is your beta carbon. So at beta carbon you have beta hydrogen. Okay, actually you have 2 there. Okay, but I just draw 1. Okay, so here the so the bond, okay, is going to form between the Cl and hydrogen. Okay, and then what happened to the bond? Okay, so to the electron inside the bond between beta hydrogen and beta carbon is that it is going to be transferred as a pi bond. So you see, in the end, you should have 3 arrows, okay, which is 1, 2, 3. Okay, all right. So now, okay, this is just going to be forming the product plus HCl. Okay, so you see the product, okay, and the steps are just similar, okay, except that, okay, this one is going with E1, another one is going with E2 mechanism. All right, okay, so in terms of mechanism, I would say that's it. Okay, so that is it for the mechanism here. Okay, so before I proceed with the substitution reaction, do you have any questions? No?
No, madam.
Okay. All right. So so let me just ask you a few things. Okay. So number one here. So this one is going to proceed with E1 or E2 mechanism.
E2.
E1 or E2?
E2. E2.
E2. Yes, correct. Okay. So why? Because this is primary alcohol. Okay. So it will proceed with E1. E2 mechanism. Okay. So should you need to do it, you do it. Right? Okay. So here, what about this one? It is going to proceed with what? What type of alcohol is this?
Tertiary.
Okay, yes, this is tertiary alcohol. So it will proceed with what kind of mechanism?
E1.
Okay, yes. So this one will proceed with E1 mechanism. So should you need to draw it, okay, you need to know the mechanism first, okay? And then, okay, let us just have a look at this one. What is the type of alcohol here?
Secondary.
Okay, so secondary. So YZ and ZG je yang jawab ni, mana pergi yang lain? Okay, so this one will proceed with E1 mechanism. Okay, if you are not focusing right now, okay, please catch up with the recording later. Okay. All right, so this one will go with E1 mechanism. So I am not going to discuss this in detail. You need to try to do it on your own because for alkyl halide, I have discussed it in details. Okay, so now I am going to proceed with the substitution reaction of alcohol. So if you remember, okay, what are the reactions that is there? Okay, so from the alcohol, okay, you see you can form alkyl halide. Okay, from alkyl halide you can form alcohol. But if you want to form alcohol to alkyl halide, okay, you need that additional step as well because the OH, remember, it is not a good leaving group. So you must make it a good leaving group. All right. Okay. So now, okay, so this one, the steps are just going to be the same. Okay. So, and as well, in terms of the mechanism, you just need to look at the types of alcohol. Okay, don't need to look at what is your acid and so on. All right, so this one as well, I am going to proceed this one with this one. Okay, so wait. Oh, I forgot to put it. Okay. Okay, so it's fine. For this one, this is primary alcohol. Okay, so this is primary alcohol. So this one will proceed with E2, Okay, this one will proceed with SN2 mechanism. Okay, so because this is substitution reaction, okay, what is it going to produce? Okay, you just need to change your OH here. So you just need to change your OH with the Cl. So you just make sure it change place. Okay, so now you're just going to have the Cl here plus H2O. Okay, because the H2O, so they just change place like this. Okay, so make sure you know how to predict the product first. All right. Okay, so now so the first step is always you need to form the H2O as the good leaving group. Okay, when it comes to alcohol, there is additional step. Okay, so that's why we teach you alkyl halide first because alkyl halide, they don't have this additional step. All right, so let us have a look here. So OH, okay, plus HCl. All right, let me just use another color. Okay, so you're going to have HCl. All right, so from here, the oxygen is going to take the hydrogen, all right? So they are going to form OH2 here. So this is going to be plus, okay? All right, and then the bond between, okay, between the Cl here and hydrogen, it is going to be broken and will be given to the Cl, okay? So you are going to form plus Cl minus, okay? So actually like this. All right, so that's it for the first step. Okay, now you just follow the step in the substitution reaction, okay? It is not going to be hard. Okay, so for substitution reaction, okay, oh sorry, I didn't draw it correctly. The structure should be here. Okay, so for this one, okay, I just want to ask you, do we attack the alpha carbon or the beta carbon when it comes to substitution? Alpha carbon, beta carbon.
Alpha.
Okay, anyone? Okay, yes, we always attack the alpha carbon because alpha carbon is the electrophilic site here. Okay, so alpha carbon, beta carbon. So here, what is going to happen is that you see the bond, the Cl, okay, the lone pair from Cl, oopsie, is going to attack the alpha carbon, okay? And then what happened to the bond between alpha carbon and oxygen? It will be sent to the oxygen, all right? Okay, so as a result, it is going to produce, okay? It is going to produce Cl, okay? And like this, all right? Okay, so plus H2O. So if you look at this one, okay, your projected product is this one, right? Okay, and when you draw the mechanism, make sure you get the same product, okay? All right. Okay, now, I didn't have it for the secondary alcohol and tertiary alcohol, okay? So the reactivity towards the substitution reaction is just this one is going to go with the SN2, okay, and this one is going with SN1. Okay, you need to take note on that. Okay, maybe it's not enough. So for next semester, I will add. Okay, now for the SN1 mechanism, okay, you should be able to do it on your own. All right, so, and the reason that I didn't put it there. Okay, so, let's see. Okay, so, okay lah, let's just discuss this one. Okay, let us just add another scheme of fractions. Okay, so I will just add it here. Okay, so let's say it is between, okay, so let us make it between tertiary, sorry. Okay, OH plus H2SO4. Okay, so now you look at this one, this is a substitution reaction. So this one is a tertiary alcohol. So it will proceed with SN1 mechanism. Okay, so this one, okay, you just need to change the OH. Apa hal H2SO4? Sorry. So alkyl halide. So let me change HBr. Okay, so now you need to change the OH and Br. So you just change Br, please. Okay, so it is going to, you should expect you will be producing, okay, so you should expect you will be producing the bromide. Okay, so plus H2O. So when you want to draw the mechanism, make sure that you will get the product back and also the side product here. Okay, so in the step 1, okay, the step 1 must be the protonation of the alcohol. It's what we call as the formation of the water as a good living group. Okay, so don't forget that step when it comes to alcohol. You cannot make the OH leave easily. Okay, because you have seen that they are not a good living group. Okay, so now let us just do it like this. Okay, and then OH. Okay, so OH here, okay, and also HBr. So now the oxygen, okay, is going to attack the hydrogen, meaning to say it is going to take the hydrogen, and the bond between hydrogen and Br is going to be broken, in which this electron, okay, wait, just now, okay, so the electron is going to go to the Br. Okay, so as a result, you are going to get like this, OH2. So this one is going to have a plus, positive charge. Okay, so plus Br minus. So the Br minus here, it is a, now it is a nucleophile. Okay, so remember the nucleophile is going to attack the alpha carbon. So this is your alpha carbon. So so this one, the bond, okay, the electron from here is going to attack the alpha carbon. Okay, sorry, this is SN2 mechanism. Okay, so that's it. Okay, so this one, the first step that will happen is that the bond breaking here. So I'm just going to copy formation of carbocation. Okay, so this is the second step. Oh my God, my sore throat. Okay, so this is step 2. So you are going to have the electron in between the alpha carbon and oxygen here. So this one is going to go to the oxygen. So as a result, okay, you are going to get it to be like this, positive charge. Okay, because this is a carbocation you're talking, and then you have H2O. Okay, so from there, okay, so from there, you are going to go with step 3. Okay, so for step 3, actually you are just going to use this carbocation. Okay, now you're going to react it back. Either you want to react with water or Br minus, there should not be a problem. So no, you need to react with Br minus because this is SN reaction. So sorry. Okay, so here I'm just going to paste it here. So so this one, this Br minus is going to attack the alpha carbon. Remember, they are going to attack the alpha carbon because they want to make bond with the alpha carbon. Okay, so it is going to form, okay, so like this. Okay, so the electron from the Br, okay, is going to be used to make bond with the alpha carbon. So as you see, this is your side product. Okay, sorry, this is your product. Okay, and then you see now it matched with what you expect in the first place. Okay, so this one is your side product and your side product is being produced. Okay, all right, so basically that is all about the alcohol's reactions. Okay, in terms of the oxidation of alcohol here, I would say you just go through this on your own. Okay, just read it through. Okay, this is not going to be really critical in terms of you don't need to know the mechanism and so on. It's just that maybe you need to just read through. Okay, so yeah, that's it. Okay, our class is just like what, 40 minutes. All right, so what you need to do is that just do the exercises that is being provided. So later, if I have time, I will provide you more exercises on this chapter. Okay, all right, so before I end the class, do you have any questions? Okay, no question. Okay, anything okay, anything you want to ask with regard to any exercises? Okay, try to do the forms, Microsoft Forms question that I did, because those are example of what we call this. Those are basically example of objective question. Okay, so if I look here right now, okay lah. Okay, the performance is like 9. Average marks is 9/15. Okay lah tu. right. Okay. But only 13 students done it. Okay, but it's fine. Okay, so if you have time, please attempt it. All right. So that's it. Okay, if you have no question, then we can end the class. I'm sorry, I cannot do the exercises and so on. My sore throat is really bad right now. Okay, bye.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Madam.